right, hey, today we're back with earthquakes, and today is a really important question. How do we locate where an earthquake actually happens? An earthquake is just ground shaking, but it doesn't tell you if it comes from the north or the south or 5 miles away or 50 miles away. We don't know. So how do scientists really determine the location of an earthquake? There are 3 steps in locating an earthquake epicenter. The first step is the time between the P wave and S wave arrival. So if you look at seismogram data, the squiggle lines, you'll see when the P waves arrive. And you'll also see when S waves arrive. And what scientists do for the first step is they come up with a time between the P wave and S wave arrival. And since seismographs, they unspool that paper at a constant rate, time is kept on the paper itself. And looking at our example, you can see that there are 5 minutes between the arrival of the P wave and the arrival of the S wave. The next step might be challenging. Step 2 is converting that time between P wave and S wave to a distance to the epicenter. And we do that using the travel time graph. The way we use this graph to determine distance to the epicenter is not like you would a normal graph. What we're looking for is the time that we recorded from step 1, so 5 minutes for our example. We're looking for where there is 5 minutes between the P wave curve and the S wave curve, vertically. And if you look really closely, you can see that there are 5 boxes, 5 minutes worth of time, right around the 3,800 kilometer mark. So using step 1, the time between the P wave and S wave, we can come up with distance to the epicenter. So that brings us to step 3, which is putting it on a map. And if we have this distance to the epicenter, away from a city, let's say Hudsonville, we recorded an earthquake, and we know that it's 3,800 kilometers away from us. All we know is that it's somewhere 3,800 kilometers away from Hudsonville. We don't know if it's north, south, east, west, where it is on the map. So what we would do if we felt an earthquake, we would just put a circle 3,800 kilometers away from Hudsonville on a map. And then we'd pick up the phone and we'd call 2 other friends. Because when we only have 1 circle, 1 city worth of data, all we know is that the earthquake happened somewhere along like that 1 circle. So we need to add more information. So we do these same 3 steps with another city. Find the time between P wave and S wave, use the graph to come up with distance to the epicenter, and we put it on a map. And when you have 2 cities, these circles will intersect in 2 places. And that's a lot better, that's a lot more helpful. Now we know the earthquake happened at one of those places where these 2 circles intersect. So then we wouldn't have to do this with a 3rd city. We'd call up another friend, same thing, same 3 steps. Time between P wave and S wave, distance to the epicenter using the graph, and putting it on a map. And if everybody did their job right, those 3 circles will all intersect in one specific location. And where all 3 circles intersect, that's where the earthquake took place. For the test and the exam, make sure you find a travel time graph and you practice coming up with these distances to the epicenter. That's something that you're going to have to be able to do. Make sure you fill in your notes about locating your earthquake epicenter. If you have questions, make sure to ask. Thanks.